the power law of logarithms. Typically in class, I'd go through this investigation with you, but I'm just going to skip to the conclusion here, which is kind of fun. So here, there's this rule. It's called the rule of 72. Okay, the rule of 72 is something that investors use in order to figure out the amount of time it will take for an investment to double. So for example, if you invest $100, how long would it take to get $200? Or if you put in $1,000, how long would it take to get $2,000? Well, the rule of 72 simply says divide 72 by the annual interest rate. And that will be a close approximation for the amount of time it will take to double the investment. So I'll leave it to you to find what the true answer would be. But the rule of 72 says if I invest something at 6%, we would divide it by 6 and we would get 12 years. And so it's approximately 12 years that it would take for your investment to double. Or if you can get it in at 2%, which is more realistic right now in our investment world, it would take 36 years for your investment to double. And again, it doesn't matter if you put in $100 or $1,000 or $1 million, the amount of time it takes for it to double is always the same. And that's kind of the fun thing with exponential functions. Okay, so I'm going to tell you about the power law of logarithms, then I'll give you a quick proof for it as well. Okay, so the power law of logarithms, we'll short form this for our work as PLOL. Okay. Well, what it says is that the log of x with a base of b to the exponent n is the same or equal to the exponent times the log of x with a base of b. So notice that n here has shifted from being as the power to being out in front here. Okay, so as before with logarithms, b needs to be greater than 0. B cannot equal 1, and x needs to be a number greater than 0, and then n is always a natural or real number. Okay, so what is the proof? I'll give you a quick proof here. So let's let w equal log of x with a base of b. Okay, then if we convert to exponential form, okay, we would get x is equal to b to the power of w. Okay? Well, this is an odd move here that we've probably never done before, but let's put both sides to the power of n. And you say that's crazy. Like before we would add 1 to one side and add 1 to the other side. That makes sense. But now we're going to put both sides to the power of n. So x to the power of n is equal to b to the power of w to the power of n. We put both sides to the power of n. And you think that's crazy. What would that help at all? Well, just follow along. Let's see what happens. Well, that gives us x to the power of n is equal to b to the power of, and remember if you have an exponent to exponent, you're just multiplying these two, so that's nw. Okay, now just because we're going to convert back, so we're going to rewrite in log form. Okay, this one's going to be a little messy here, but remember the exponent right here is what it is equal to. So nw is equal to, and we got log of x to the power of n with a base of b. Okay, this is the converting from exponential form to logarithmic form. Okay, now remember at the very beginning we said w is equal to log of x with a base of b. So we're going to take this w right here and we're going to replace it, substitute in log of x with a base of b. So that gives us log x to the power of n with a base of b is equal to n times log of x with a base of b. And check this out. The n power right here has moved into the in front of the log. There you go. So this is the proof of the law of logarithms. Okay, it's a bit of a weird law, hard to understand, and it will take some playfulness for you to get into the mode where you understand how to use it, where to use it, and maybe even understand why it is just true. Okay, so let's use that law to evaluate a couple things here. So the power law of logarithms says that this right here, we could shift it out in front, and we would have 4 log 9 with a base of 3. So these two things are equal. Now, we're trying to flex our muscle here, use no calculator to solve these problems. So we get 4 log. What we're going to do is we're going to try and make this, because the base is 3, we're going to try and write 9 in terms of 3 to the power of something. Okay? So again, base of 3, and 9 is just 3 squared. Again, we can use our power law of logarithms right here. Okay, and we can shift this 2 out in front now because it's a power. Well, that's 4 times 2, which is 8 log 3 with a base of 3. And if you remember, log of 3 with a base of 3, log 3 with a base of 3 is just equal to 1. So the answer here is just 8. Okay, let's try another one of these. So again, power law of logarithms means move it out in front. So we get 5 log 8 with a base of 2. Again, we're going to try and write the 8 there in terms of 2 to the power of something. Well, 8 equals 2 to the power of 3. So we're going to write down 3 here. Okay, power law of logarithms again says that we can take this 3 and shift it out in front. So we get 5 times 3, which is 15, with log of 2, base 2. And log of 2 with a base of 2 is just 1, so the answer is 15. All right, let's do this again. Take the 2, move it out in front, the exponent there. So it's 2 log 0.001. Now remember, if there is no base, the base is 10 because it's the common logarithm. So we have 2 log 10. And 10 to the power of what equals 0.001? Well, that's negative 3. Again, we take this exponent, we move it out in front by the power law of logarithms, and 2 times negative 3 is negative 6. And we have log of 10 with a base of 10, which is just 1. So that's negative 6. All right, one more time here. This one's a little messier. So we have log 5, and you have a square root. Well, remember that if you have square root of 125, that is 125 to the power of 1 over 2. That's how you write a radical as an exponent. So I have 125 to the power of a half. We use the power of logarithms, power law of logarithms to move that out in front. So the exponent's now out in front. We have log 125 with a base of 5. Use our same rules again. So we're going to write 125 in terms of 5 to the power of what? So 5 to the power of 3 equals 125. Again, power law of logarithms, move it out in front. We get 3 times a half, which is 1.5 log 5 with a base of 5. Well, log 5 with the base of 5 is just 1, so we have 1.5 as our answer. Or 3 over 2 if you prefer to answer it that way. All right, pretty powerful stuff there. All right, let's solve for x here in 3 equals log 2 to the power of x. Okay, for this one, we're going to again use, notice that this is the power law of logarithms there, so we can move this out in front. So we got 3 equals x times log 2. And if you're trying to get x by itself, we're going to divide both sides by log of 2. Now we have x equals 3 over log 2. And x, or 3 divided by log of 2, is 9.97, let's say, approximately. Okay, this is our exact answer. This is a beautiful answer. This, the last line here is an approximate answer. Okay, the power law can be very useful when solving for exponential equations. So remember, in grade 11, you were only able to solve for the exponent by guessing and checking. So we can do one better this year, and we can actually solve for the exact value. Again, there's a couple ways we can solve most of these problems, but let's use let's use the power law of logarithms. No, okay, we're going to just convert this one. Let's make this an easier problem. Let's just convert to exponential form. I'm going to first start this by just converting to exponential form. So to rewrite this, we would have log of 12 with a base of 5 equals x. There you go. We have the exact answer right there. If we want to know how to do this in a calculator, some of you don't have this button, but you do know how to figure this out. So log 12 divided by log 5. And so then x would be approximately 1.544. Okay, so that's how we do it if we just converted between the two forms. But let's try this again. This time we're going to use the power law of logarithms to do this. And this is a bit of a crazy move again, okay? So we're going to take the log of both sides, which seems crazy. So we have log 6 to the power of x equals log 100. So we just took the log of both sides. Remember, if you do this something to the left and the right side, you're dealing with your equation properly. So the power law of logarithms says that we can take this x now, the exponent, and move it out in front. So we have x log 6 equals log 100. If we're trying to get x by itself, we can divide both sides by log 6. Now on the left side, we just have x on its own, and we have log 100 over log 6. Just for fun, let's state this another way, log of 100 with a base of 6. Notice that those two things would be equal. And if you wanted to know the approximate answer using your calculator, it would be 2.57 approximately. So again, note that using the change of base formula, any logarithm can be expressed in terms of common logarithms, which many of your calculators are stuck to common logarithms, so we can rewrite it using this. Okay. And this was a quick lesson here on the power law of logarithms. Enjoy.